Here is an example. We're talking about a dipole, electric dipole. An electric dipole consists of 0.9 grams spheres charged to 1.8 nanocoulombs. So one is positive charge, another one is negative charge. So basically what we have here, we have a dipole, okay, which has a positive charge and negative charge there, and the charge value is 1.8 nanocoulombs here, positive charge, here it is 1.8 nanocoulombs negative charge. Now at the end of it, 11 centimeter long massless rod, assuming that's a massless rod. So the length of this rod is given, which is 11 centimeter. Okay, 11 centimeter. Now the dipole rotates on a frictionless pivot at its center. The dipole is held perpendicular to a uniform electric field with a field strength of, so here we have a constant field strength. So basically it could be a capacitor where one plate has positive charge, another plate has negative charge. So definitely here we have a constant electric field. That electric field value is given E equal to 1030 volt per meter. Now the question is asking about what is the dipole's angular velocity omega at the instant of the aligned with the electric field. So what happens here? We know that same charges reflect each other, opposite charges attract each other, so this is going to rotate. This is set up on a pivot point. So basically what happens, it will rotate and it will be something like this. It will rotate. It's a frictionless rotation, so basically it's going to continue rotating because of the inertia. But the goal is, he is asking us to find out what is the angular velocity omega at this point. Okay, so here also we're going to use the law of conservation of energy. Kinetic energy final must be equal to the potential energy final, equal to kinetic energy initial plus potential energy initial. So kinetic energy final is half I omega square. I is moment of inertia, omega is the angular velocity. That's what we need to find. So we're looking at the final value plus potential energy final. So once it moved in the direction, potential energy is, the formula is dipole momentum times electric field times cos theta, where P is a dipole momentum. The P value here is Q times S, where Q is the charge. We know the charge value. We know the S is the distance from the pivot point. Okay. And here theta is angle between the electric field and the dipole. So electric field and dipole. So in this case here theta is 90 degrees. By the way, that's initial condition. In this case theta equal to 0 degrees. This is the final condition. So KE final, which is half I omega square plus PE, in this case Q times S times, we know the electric field, which is 1030, that's what given, volt per meter. I know the Q value, I know the distance too, which is 5.5 centimeters, must be equal to K initial kinetic energy is 0. Okay, and PE must be here, initially theta is 90 degrees, cos 90 is 0, so I can take that as 0. Okay, so here I think I forgot to mention, okay, so PE is negative PE cos theta, so when it goes to the other side it will become negative of negative, it will become positive. So half I omega square equal to negative of negative charge, we know, which is 1.8 nanocoulombs, 1.8 times 10 to the power of minus 9, and S is the distance, which is 11 centimeter, 5.5 centimeter. So 5.5 times 10 to the power of minus 2 times 1030. So the I dipole momentum I equal to half times, not half, I believe it's 2 times mass times r square. So I'm going to substitute it here. So we'll end up with half and 2 times mass is given, which is 0.9 grams. So I'm going to take that as 0.9 times 10 to the power of minus 3, convert that into kilograms, and r square, the distance is, we know, which is 5.5 centimeter, so I'm convert that into meter, whole square, omega square equal to 10.18 times 10 to the power of minus 8. Now my goal is finding the omega. 2 to get cancelled out. So after substituting the values, I end up with the omega square equal to, or omega equal to 0.193 radians per second. So here are the calculations. Thank you.